So Leanne has an MPH from the School of Public Health at UC Berkeley, and she is a senior scientist at PSE Energy. I included in the chat a link to her biography for anyone who wants to take a more detailed look, but her focus at PSE Healthy Energy is on the impacts of energy production and use on human health, the environment, and climate. And again, we are incredibly grateful to have her with us today sharing her expertise. Leanne has about 40 or 45 minutes worth of educational content for us. She's going to be using slides that we'll all be able to see in a second. And then we'd like to give the last 15 or 20 minutes of the call, we'd like to open it up to questions from everyone who's on the call. The way that we would like to do that is if you have a question, please message me in the chat with what it is and who you are, and I can read it out, and I will also write back to you and clarify, if anything needs to be clarified. Alrighty, so I think on that note, we will turn it over to Leanne. And if you're not already muted, if you can mute yourself just to eliminate any background noise, that would be fabulous.
All right, can everyone hear me? Amanda, maybe you can confirm.
I can hear you.
Great, great. And then I guess I'll be speaking, so the screen may just pop up, but as long as you can see my slides, you may also want to pin my video to make sure there's no interruption in the slides that you're able to see. So great, thank you so much for asking me to speak with you all today. As Amanda mentioned, I'm a MPH by training, so it's great to be on the call with fellow health professionals and health students, and to speak with you about the various public health dimensions of oil and gas development here in California. So for those of you that are not familiar with PSE, physicians, scientists, and engineers for Healthy Energy, we are a nonprofit energy research institute, and we study the way that energy production and use impact public health, the environment, and climate. And as such, our work is highly interdisciplinary. We have folks with varied expertise on our staff and that we work with externally, including those with perspectives in engineering and environmental science and public health. We conduct our own original scientific research in-house, so we publish things like peer-reviewed publications and technical reports and data visualization tools. We also heavily focus our efforts on translating existing research for varied audiences, including advocacy groups and policymakers, and we disseminate scientific information to inform data-driven policy and decision-making at the local, state, and federal level. So with all that being said, a brief outline of what I'll be discussing today. I'm going to provide just a high-level overview of what oil and gas development looks like here in the state of California. I'll discuss some public health risk factors associated with oil and gas development to provide a framework for discussing these issues from a public health perspective. And I'll also be focusing heavily on what we know about proximity to oil and gas development and health, including proximity for populations here in California and the findings of epidemiological peer-reviewed literature from across the United States and how that literature may be applied here in the California context. And I'll end with a couple key takeaways. So jumping right into things, oil and gas extraction techniques in California primarily fall into two larger buckets, well stimulation or enhanced oil recovery. And largely in California, in certain areas, we're talking mainly about oil, although oil and gas is produced in the state. So to start with well stimulation, different types of well stimulation include things like hydraulic fracturing, matrix acidizing, and acid fracturing. And hydraulic fracturing may be something that you've heard of before. It's commonly called fracking. You may have heard about it here in the state of California or also on the national debate stage. But the key point being that hydraulic fracturing actually looks very different here in California than in other parts of the country. So while in places like Pennsylvania and other shale plays, you have what you see all in the graphic all the way on the left-hand side, where production wells are drilled very deep into the subsurface, thousands of meters deep, vertically, and then end up being drawn horizontally into source rock. In hydraulic fracturing in general, the process tends to be the same. It's the injection of water and sand and proppants and certain chemicals to help increase the pressure in the subsurface, allow for the fracturing of the source rock to increase the amount of oil and gas that can eventually be recovered up through the production well. So that's the example on the left-hand side is what's typically seen in places like the Marcellus Shale. However, in California, hydraulic fracturing looks a bit different. Typically, we're talking much shallower depths, maybe hundreds of meters rather than thousands, with a bit less water and inputs in order to be able to extract the oil and gas, typically from migrated oil formations. So as of 2015, about 20% of the oil and gas in the state of California was actually produced using hydraulic fracturing, with much smaller proportion of oil and gas being produced using matrix acidizing, which essentially uses the injection of different acids to dissolve the target geological formation, and an even smaller percentage using kind of a combination of increased pressure from a fracturing technique and also the injection of acid through acid fracturing. So again, the big takeaway for well stimulation is hydraulic fracturing is the primary form of well stimulation in the state. However, the largest amount of oil and gas, oil primarily in the state of California, is actually extracted using enhanced oil recovery techniques, or EOR. And these include things such as water flooding, steam flooding, and cyclic steam injection. And essentially, EOR is the process of increasing the amount of oil that can be recovered from an oil reservoir, typically by injecting a substance like water or steam to increase the pressure in the subsurface and also help reduce the viscosity of the oil. And that allows it to be collected more readily. And again, the majority of oil production in the state is facilitated by enhanced oil recovery techniques. So just to give an idea of what this looks like geographically throughout the state, the majority of oil and gas development in California primarily occurs in the central and southern portions of the state. And you'll see different sedimentary basins in the gray underlay in this map. And you'll notice that the majority of oil and gas is produced in the San Joaquin Basin, followed by the Los Angeles Basin, and then Ventura. And the lighter colors in both green and in the red or pink show the proportion of oil and gas being produced in these basins from fracturing. So as you can see in each of these circles, a much smaller proportion of oil and gas is extracted using fracturing techniques as compared to other types of oil and gas extraction like EOR. So there's been a lot of interest in hydraulic fracturing and well stimulation from the general public and policymakers. There's been concerns about different hazards and risks associated with impacts to air quality, water quality, induced seismicity, and public health. And because of these concerns, the California legislature passed Senate Bill 4 back in 2013, which essentially prompted a large-scale scientific assessment about the hazard, risks, and impacts of well stimulation here in the state of California. This was conducted by the California Council on Science and Technology, or CCST, and it resulted in a multi-volume, multi-chapter assessment that's currently available online. You can see all of the chapters there are actually linked at the bottom. But I've highlighted 2 chapters here today that actually focus on the potential impacts of well stimulation on human health in California more broadly, with a case study deep dive into the Los Angeles Basin, where you again see significant oil and gas development, and you also have large population density in that area. And I mentioned this to to give a little bit of background about the legislation and about these scientific assessments that came out in 2015, because they provide a really great framework to be able to talk about the public health risk factors associated with oil and gas development in California, again, from a public health perspective. So these are the public health risk factors identified from that initial report, and I'm going to be talking in more detail about the first 5 today. So we'll be talking about chemical usage in oil and gas development, about what happens with water that's co-produced with oil and gas development, how it's reused and disposed throughout the state, and also what we know about air pollution that's associated with oil and gas development and the relevance for nearby communities in proximity to this development. So starting with chemical usage in oil and gas development, the California Council on Science and Technology report in 2015 found that oil and gas operators had very few restrictions on the types of chemicals that were used for different well stimulation treatments. And in California at that time, more than 500 chemicals had been reported by operators either through a voluntary basis or on a mandatory basis. And Senate Bill 4 mandated chemical disclosure for well stimulation chemicals, but chemicals can still be reported as trade secrets or proprietary. And that essentially means that there can be no further investigation into any kind of hazard or toxicological or chemical properties. It's basically still an open question about those trade secret chemicals. And finally, there's a large number of chemicals used and that have limited information. Their toxicological profiles may not be well assessed. They may not have different chemical and physical properties determined. And that again makes it really difficult to assess any public health risks that may be posed by the release of these chemicals, either through stimulation fluids or as they volatilize and enter the environment. So since this report in 2015, there's been more of an evaluation of chemical usage in oil and gas development more broadly beyond well stimulation, and multiple studies and different chemical disclosure databases in the state of California have found that chemical use in oil and gas development is actually fairly widespread. It's not restricted to particular well stimulation techniques. There's significant overlap in the number of chemicals used and the types of chemicals used in routine oil and gas operations like well maintenance, for example. So from a public health perspective, it's really important to be considering chemical usage very broadly in all types of oil and gas development, given the overlap in chemical usage. And this holds implication for the water that is co-produced with oil and gas development. This water that tends to come up from a well in multiple types of oil and gas extraction can contain salts, residual petroleum hydrocarbons, microbes, chemical additives, and transformation byproducts of things that occur in the subsurface. And for over 3 decades now in the Central Valley, there's been this practice of reusing oil field wastewater for crop irrigation, where the water is essentially blended with additional water sources so that it meets certain salinity standards for crop irrigation. And the most recent information I could find, these different crops that are shown here were irrigated with blended oil field produced water in 2018. So if you look through this list, you'll see different root crops, things grown in the ground, carrots and potatoes, many crops like fruits and nuts grown on trees, and other crops grown directly on the surface, tomatoes and wheat, for example. And just to add here that organic certification doesn't typically consider the source of irrigation water used, and so purchasing organic is not necessarily a way to avoid consuming crops that have been irrigated with this blended oil field produced water. So this practice of reusing oil field wastewater for crop irrigation really came to light in the public after the CCST report in 2015. And so the Central Valley Regional Water Quality Control Board convened a food safety expert panel to evaluate this practice for crop irrigation in California. And so I've provided a link below to their website if you're interested in learning more about the different materials that they've produced, but there's been more information that's come out through this process, through additional legislation and reporting requirements. So we now know which oil fields send water for agricultural irrigation, which chemicals are used downhole at these wells that have been disclosed at a particular point in time through Assembly Bill 1328. We have some water quality results from quarterly testing of effluent after the water has been treated. However, there still are many challenges and public health questions regarding this practice. For example, a point-in-time chemical disclosure doesn't necessarily reflect the current chemical landscape, as chemical use can vary by well and over time as practices change. There's also a lack of standard EPA analytical methods to be able to test for these suites of chemicals in water. So you have questions about accurate testing for all the chemicals. There's also a lack of toxicity information, as I had mentioned before, and an even broader question about what chemical transformations may occur. So while chemical disclosures, you may be disclosing a parent compound that may be injected down a well, after these chemical additives and naturally occurring substances interact with one another in the subsurface under high heat and pressure, there's remaining questions about what chemical transformations may occur and what daughter products may form. And finally, the uptake of these different compounds into food crops can really vary by the crop. Does it end up in the edible portion of the crop, et cetera? So there's lots of open questions. And again, if you're interested in this issue, I encourage you to check out the Water Board's website here at the bottom, as they provide ongoing information that the food safety expert panel is working on. So in addition to reusing oil field wastewater, which I should say a very small proportion of the wastewater produced in the state is actually used for irrigation. Additionally, about 1% of the wastewater produced in the state is sent to these unlined evaporation or percolation ponds. Essentially, the water sits in an unlined pond and can either evaporate into the air, which may include volatilization of particular volatile compounds into the air near these ponds. But essentially, the water is meant to percolate in these unlined ponds through the soils to recharge the aquifers in the subsurface. And typically, these ponds are sited in areas where aquifers have been designated not of suitable quality for drinking water now or in the future, primarily due to salinity. And the same is true with class 2 underground injection control wells. So these disposal wells account for the largest proportion of oil-filled wastewater disposal in the state, where essentially produced water is just injected in the subsurface for disposal, again, in aquifers that are typically not deemed suitable for current or future drinking water use. However, there have been some instances in the past, issues with the permitting process, where there have been these wells permitted and oil operators permitted to inject into aquifers that actually did have underground source of drinking water USDW designation. And switching gears now from water pathways to discuss air, air pollutants are emitted either directly or indirectly from surface or subsurface oil and gas equipment. So this can include things like pumps and compressors from the wells themselves, or pneumatic devices from storage and separator tanks. Air pollutants can also be emitted during certain oil and gas activities, like from liquid and solid waste handling and from venting and flaring of gases. And many of these air pollutants we know have specific relevance for human health. Many hazardous air pollutants, or HAPs, are emitted during different oil and gas processes. Again, HAPs are designated under the Clean Air Act and are known for adverse impacts to human health for a variety of different ways. The HAPs list also significantly overlaps with the toxic air contaminants list here in California. So you may be more familiar with TACs, but that list has very significant overlap. Oil and gas activity also emits various criteria pollutants, including particulate matter, which we know has particular relevance for respiratory and cardiovascular health, among other health outcomes. And also, oil and gas activities may emit certain ozone precursors into the air, which when they interact in the atmosphere and with sunlight can end up forming ozone, which we know is very relevant for respiratory health. And so I've included a figure here on the right-hand side from a recent paper, Garcia-Gonzalez et al. In 2019, that essentially looked at hazardous air pollutants that had been detected or reported throughout various different activities at the well pad. And so you can see various hazardous air pollutants listed, some of them overlapping for different types of oil and gas processes. And again, these were all reported in the peer-reviewed literature as being detected. So again, similar to chemical usage, when we're talking about air pollution, it really makes sense to talk about this issue very broadly regarding oil and gas development, as air pollutants can be emitted during different phases of development and during different oil and gas activities. And air pollution is particularly relevant when we're talking about proximity to oil and gas development for communities that, you know, live, work, and play directly adjacent to oil and gas activities. And a recent study estimated that about 2 million Californians live within approximately 1 mile of an active oil and gas well. And the majority of those individuals actually live in the Los Angeles basin, which is fairly unique because it has a substantial natural concentration of oil, of crude oil, directly beneath a dense urban population, essentially a global megacity. So if you may have seen some of these images previously, but this is just, these images on the right are examples of what community and oil and gas interface looks like in the Los Angeles region. So back in 2018, at PSE, we were actually retained by the Office of Petroleum and Natural Gas Administration and Safety for the City of Los Angeles to conduct a review of the peer-reviewed literature that focused on public health and oil and gas development, and specifically air pathways. And the idea was to assess the applicability of peer-reviewed literature across the United States to the context of the city of Los Angeles and in California in general. And I'm providing a couple links here to this report in the bottom. It's a wealth of information, and I highly recommend, if you're interested in looking at specific studies, to go ahead and check it out. It's a good summary. So essentially what this report includes is the studies that had previously been evaluated in the CCST SB4 report that focused on air pollution and health, or that were health outcome studies. We also identified additional studies between 2015 and 2018 that again looked at local air pollution and health, or health outcome studies related to oil and gas development. And again, the report includes a review of each study. We discuss different study designs, strengths and limitations, and we also include a very detailed summary table. That's a great reference as well. And this slide is a bit overwhelming, but I'm going to walk you through it. Essentially, only a couple studies actually looked at distances less than 1,500 feet. The majority of studies, for reasons probably related to sample size and things like that, looked at exposures at distances beyond 1,500 feet. So I'll go over some of these ones in a little bit more detail. So starting from the top, studies that look at proximities for people living within 500 feet of oil and gas development. 2 studies in Colorado observed increased cancer risks based on particular air pollutant concentrations. And the thing to note here is that these studies are actually a bit stronger because they actually include air pollutant measurements in their assessment to kind of evaluate exposure. So one study in particular, McKenzie et al. 2018, found 8.3 cancer cases per 10,000, which exceeds the US EPA upper threshold for acceptable risk, which is 1 in 10,000. Additionally, within 500 feet, there were exceeded permissible noise levels, and one study observed actually no increased cancer risk, although we'll note that the air monitoring included in that study was restricted to polycyclic aromatic hydrocarbons only, and didn't evaluate the broader suite of air pollutants that we know to be associated with oil and gas activities. Within 1,000 feet, one study observed elevated noise levels from compressor stations at levels at which adverse health effects like sleep disturbance and insomnia had been reported. And within 1,500 feet, I've actually have this particular study in a box. This is the only peer-reviewed study in the state of California currently. And this study essentially looked at 1,500-foot buffer zones around 2 drill sites in the Los Angeles area, and used health surveys and questionnaires and found that physician-diagnosed asthma rates within these buffer zones were higher than state-level and county-level surveys. And also asthma prevalence was also higher within the 1500 buffer zone as compared to Los Angeles County. Additionally, I wanted to note there was a peer-reviewed publication that included a survey of health experts that convened and determined that a minimum safe distance from unconventional oil and gas development is 1/4 mile or 1,320 feet, and that additional setbacks should be considered for vulnerable groups. Now, as I mentioned, the majority of studies ended up evaluating health hazards, risks, and impacts associated with oil and gas development at further distances, say 2,500 feet and beyond. So at these further distances, elevated noise levels were still observed associated with annoyance, sleep disturbance, and cardiovascular impacts. Adverse birth outcomes have also been observed, low birth weight, small for gestational age, certain birth defects and preterm birth. Increased non-cancer and cancer risks have been observed, as well as increased odds for particular childhood cancer, acute lymphocytic leukemia, and other acute adverse health outcomes have been reported at these distances, like headache and fatigue. One study that looked at air pollutant concentrations from a drill site did find that maximum VOC concentrations did not exceed a health-based screening metric, the US EPA regional screening levels, beyond 2,500 feet. Again, that study looked at air pollution concentrations and didn't extrapolate out to health outcomes necessarily. And finally, in more recent years, rather than reporting findings by distance or by well density, certain epidemiologists have created these combined exposure metrics or indices that combine one's proximity to a well pad, the well density near where someone lives, and the activity occurring at the well pad into a combined exposure metric. And I wanted to be sure to note the findings observed from these more combined exposure metrics. So things like mild asthma exacerbations associated with the higher exposed group, increased markers of cardiovascular disease, preterm birth and physician-reported high-risk pregnancy, depressive symptoms, chronic rhinosinusitis, migraine, and fatigue. And so, as I had mentioned, only one peer-reviewed study currently exists in the state of California. And as some of you may be very familiar with, it takes a long time to build up a body of literature, to conduct a study, and to go ahead and publish it. And so given decision-making that is happening here in the state of California, it's important to look at the full body of evidence and try to assess the applicability of what's currently available to the California context to help inform decision-making. So in our report to the Office of the Petroleum Administrator, we include a variety of different variables that can be considered when assessing the applicability of particular epi studies to see if they may be relevant for the California context. And so these variables include things like the type of petroleum reservoir, the type of hydrocarbon being produced, is it oil or gas or both, the extraction method to production, is it high volume hydraulic fracturing or enhanced oil recovery methods, the types and intensities of emissions of criteria and hazardous air pollutants, if that information is available, the regulatory environment, are there emissions controls regulations implemented in these different regions? And finally, the density of oil and gas development and the density and the demographics of human populations that live near oil and gas development. And what we ended up finding is that the studies from Colorado actually pretty closely align with what we see in the California context, in that the petroleum geology can be similar in certain parts of each state, looking at migrated oil or migrated oil and source rock. The hydrocarbon produced, in some cases, it's just oil, but more commonly oil and gas. The extraction methods tend to be fairly similar. And the well density examined in some of these studies actually is similar to the well density observed within the city of Los Angeles in particular. While California has a methane rule, Colorado also has methane emissions rules that may also reduce co-emitted health damaging air pollutants, such as volatile organic compounds. And so for these studies specifically in Colorado, health risks were observed with increased proximity and increased well density. So again, to summarize these risks from these Colorado studies, increased non-cancer and cancer risks were observed, increased incidence of congenital heart defects and neural tube defects, increased odds of developing acute lymphocytic leukemia, and increased markers of cardiovascular disease from these Colorado studies. And as you're probably aware, currently in California, there is no statewide setback for oil and gas development. So one of the things we did in our report is we kind of laid out what current setbacks are available from oil and gas development in different states, in different cities across the United States. And this is just the California example to show that certain local setbacks exist out to 750 feet. And certain reporting notifications requirements occur for sensitive receptors out to 1,500 feet. And again, I would point you back to our full report if you're interested in looking at what setback distances look like for other states potentially. So the broad takeaways here are that various health hazards, risks, and impacts are associated with oil and gas development more broadly, not just associated with well stimulation or hydraulic fracturing specifically. So again, when we're talking about things like chemical usage in oil and gas development, we should consider things like routine oil and gas activities and what chemicals are used to maintain a well, alongside what chemicals may be used to, say, stimulate a well. And also air pollutants known specifically to that are health damaging are associated with various stages of oil and gas development. And so again, it makes sense to look at the activities more broadly, as opposed to just focusing on specific stimulation techniques. And while one peer-reviewed study to date focused in California, there are many studies in Colorado where there's similar petroleum geology, hydrocarbon production, extraction techniques, and emission control regulations that may be, these studies may be particularly relevant for the California context. And more broadly, studies to date conducted in areas specifically with migrated hydrocarbon reservoirs, like migrated oil, similar to California, have observed increased health risks associated with oil and gas development, ranging from approximately 500 feet out to a mile. And public health protective measures that we've kind of touched on briefly throughout the course of the presentations for communities. These protective measures may include things like minimum surface setback distances, the utilization of best available emissions control technology, continuous fence line air monitoring, and I'll just emphasize continuous there to be able to capture any kind of episodic emissions that are known to be associated with oil and gas development, and continued health surveillance and health studies. And to end, our study really, while we looked at distance from oil and gas development, we also ended up finding that typically protective measures should be considered both for distance from and density of nearby oil and gas wells, as well as the density and demographics of nearby populations. So I went through all of that pretty fast, but I'm happy to have a discussion and answer any questions that folks may have.
And thank you so much. That was a lot to digest, but so relevant and interesting. We do have quite a number of people on the call, so I think we will, if people have questions, you can message me. I'm Amanda Milstein. You can send me a message in the chat and unmute yourself and speak up if you're having trouble doing that. I'll start off with just a quick question, Leanne, and I apologize if I missed this, but I'm wondering for slide 20, in the discussion of the Colorado study, is there a specific number of feet that the McKenzie et al. Study looked at? Was that, what was the setback there?
Yeah, so the McKenzie studies look at a range of distances. Obviously, this author has been following these issues for a while and has kind of adapted methods. So some of her more recent studies use that combined exposure metric that I had mentioned, looking at proximity and density and activity at the well pad. The study that I'll point you to specifically that was very strong and published recently, and I'm going to go back a couple slides. McKenzie et al. In 2018, this study actually estimated cancer rates based on a pretty comprehensive set of air pollutant measurements over time. Colorado has been doing a lot of air quality sampling and monitoring and has a lot of air pollutant measurements available. And so the increased cancer risks observed in this study, 8.3 cases per 10,000, is actually fairly substantial to be seeing within 500 feet of oil and gas development. So that would be, this study found these increased cancer risks at in the closest proximity. And as I mentioned, many of the other studies just happen to look at, larger distances just likely because of sample size and needing to have more individuals to assess, health associations with health outcomes.
Alrighty, so we're getting in some questions here. So Leanne, I'm just gonna start sharing these out with you.
Sure.
So let's see. So somebody is asking, what about radioactivity of produced water?
Yeah, it's a great point. And I specifically didn't touch on it too much today because in other parts of the country, naturally occurring radioactive materials or norms are commonly found in high concentrations in produced water and are kind of a large limitation to being able to reuse or handle or dispose of that produced water. So the Marcellus Shale in Pennsylvania in particular has very high concentrations of like radium and strontium, for example, coming up with the oil and gas. In California, actually, that's typically not the case, and radioactive, just because of the type of formations that we have here, norms are not as much of a consideration. They're not as much of a limiting factor here in California as compared to other places in the country.
Does well wastewater ever get routed into community drinking water sources?
No, not to my knowledge. So in talking about the water pathways, it's a little bit more complicated. It's essentially, the question is around what indirect exposure may occur. So if you have produced water that enters into an aquifer, say from a produced water pond as it's intended, but then that produced water migrates in the subsurface and enters regions in an aquifer that would be tapped for drinking water or for irrigation use, either now or in the future. That's something that's definitely an open question. There has been some surface water discharge of oil field produced water here in the state of California. However, I think that the volumes that had been discharged to surface water had been very minimal, and I'm actually not certain that that practice is still occurring in the state. That's something I would have to check up on.
Okay, I'm trying to group these questions together. Thank you guys these are wonderful questions that are coming in. So on the topic of water specifically, somebody's asking if there's data about the health harms of people eating produce that's watered with oil field produced water?
Yeah, it's a very good question, and there are so many considerations when it comes to crop testing. I had mentioned that there's a lack of standardized EPA like analytical methods to look at chemicals just in water. When you plan to test crops, the issue gets even harder to assess. So while I am not aware of any health outcomes being reported as, health effects being reported from consuming crops that have been irrigated with produced water, it's been hard to test to see what exactly the uptake of these compounds in the crops may be. And again, using citrus as an example, if there is any uptake, is it occurring in the rind that typically isn't consumed but may sometimes be, zested or consumed, or does it end up in the body of the fruit? So there are lots of, continuous questions about this practice.
Relatedly, do you know anything about the volumes of water that are used? And I think specifically thinking about drought conditions in California and water shortages here. Is there, is that something you can speak to?
I think that when it comes to water considerations in the state, and one reason that I think that water has been historically reused for crop irrigation is particularly in this region. There is, in the Central Valley, there's obviously a lot of agricultural activities happening, and there's also, been limited water access in that region, and so it makes sense as to why this would be maybe considered in this area, especially given that the water in this area, from certain wells in this area, also doesn't have very high salinity. So I see why the water ends up being reused that way. In terms of specific volumes, I would love to be able to follow up with this question. We have a publication that we worked on last year that we are waiting to be released, and I'm happy to follow up with folks as soon as that publication is released, and we can share the findings of that, where we look at water use associated with oil and gas development statewide. But I would say that in terms of the proportions of water that end up being reused or disposed, it's really a regional question about, how many people are living in a particular region and would need access to the water, what other activities requiring water like agriculture or livestock watering are necessary, and yeah, so what are the competing interests in that area?
Okay. I'm going to switch gears slightly away, specifically from water. Somebody is asking, is there a certain distance or buffer zone your organization, so PSE, or the research that you guys are aware of or have conducted, recommend between oil and gas and housing specifically?
I think I didn't hear the very end of that. Between oil and gas and what?
Housing, residential
housing. Yeah. So in our report, we present a range, because we present a range of areas where health impacts have been observed, and we also recognize. I'm just going to go back to the end here. We also recognize that distance alone is one way to consider how someone may be exposed, but exposure may be, significantly greater if you have, say, 5 or 10 wells located within a particular distance from your home, as opposed to one well. And so that's why we present exactly what the literature has shown, which is a range of health risks or increased health outcomes being observed at distances from 500 feet to out to a mile.
Thinking, I guess, again, a little bit more broadly in terms of what as health providers speaking at these pre-roll meetings, someone's asking if you had to consolidate what the most critical health impacts are into, let's say, 2 or 3 talking points, considering that each of us may have 2 minutes to speak. What would you say those key points should be?
I think that what's been observed in the literature, and I think that what I have heard is of concern for folks, are some of the more acute impacts that may be impacting respiratory health. And so there are studies that have shown, increases in different respiratory outcomes, things like asthma and others that I think may be particularly relevant for folks to consider, especially given the high asthma rates observed in some areas where there is oil and gas development and other industrial activities.
Someone's asking, do oil companies have any health disclosure requirements to property owners, or I would add to that, anybody, like anyone who is living, working, going to school near sites of oil and gas extraction currently, like when they lease that land or when they make changes to their production practices?
Yeah, that's a really good question. I'm not sure when, like, say when land changes hands, or when, you know, it may be leased to someone that's not owning it, but renting it. I'm not aware of any kind of notification there. I know that through the South Coast Air Quality Management District, there is a notification system required within 1,500 feet of sensitive receptors, based on, I believe, chemical usage and well activity, again, within that air basin. So I am aware of that notification, but in terms of actual notification around, you know, purchasing of land and things like that, I'm not aware of any notification.
Someone wants to know if PSE is addressing AB 1402. I'm not familiar with that, but this person is saying it requires pipelines to be inspected. Is that something you guys are involved in?
So we have many people on our staff that are working on a variety of issues. I can say that I have a lot of projects happening right now, and AB 1402 is not currently on my list, but I am happy to go ahead and look into that a little more thoroughly to see what's happening there.
And then Leanne, I think more broadly, and I know Linda, perhaps this might be a good place to bring you in as well. Somebody is asking sort of this big picture question of what would be an ideal outcome of these I think I'm going to narrow this question a little bit to say of the health voice speaking at these pre-rulemaking hearings. And Leanne, I'd love to hear your thoughts, and Linda, I think if you can chime in on that as well.
Yeah, I think that as public health professionals, people really want to hear what you have to say. And I think that you can have a unified message, but there's also ways to present, you know, various nitty-gritty elements of what is shown in the literature. But in terms of broader strategy, I definitely would pass that on to Linda to get her guidance on that, because that's beyond my area of expertise.
Yeah, this is Linda. I think I just second what Leanne just said. I think that it's great to have an overview, and I also think it's great to go into a little bit more detail so that we can demonstrate A, our expertise, and B, that there is, you know, there's not a huge amount in the literature. There's very little in California, but there's enough for us to say that at the very least we need the state to take a precautionary and preventive approach to the protection of particularly sensitive populations. And that, you know, especially when we're talking about things like cancer risk or asthma in children or adverse reproductive outcomes, which I think are some of the health outcomes that I would really highlight in the hearing, with reference to these other super important things like, oh, let's just contaminate the rest of our available drinking water in the state as we enter into another drought. You know, so I think we have an opportunity to, if we can sort of figure out, you know, who all is going to be at these hearings, or particularly the LA and Oakland hearings, where I think we should be repeating basically the same set of talking points, we can provide an overall view and hone in on some of the specifics that Leanne has very eloquently laid out for us, but all with the same message that we want the state, you know, that the literature shows that there are risks, and it's incumbent on the state to take a precautionary and preventive approach so that we aren't in the position of documenting adverse health outcomes in children and adults, you know, 10 years down the line because the state didn't take the steps that should have been taken. I would be personally cautious about saying it should be at this number of feet for a setback, because I'm curious if Leanne has a different perspective, but I'm not seeing that there's some safe setback level. and I don't think the data is there to say what a safe setback level would be. And I also do think that it's important for us to make points about the need for better monitoring, better health surveillance, and better disclosure, getting rid of the trade secrets requirement, and I don't know what else.
Yeah, I will just jump in after what Linda added about presenting a specific distance or a range, and just say that in an ideal situation, it would be great to have a range of studies that look at a wider range of distances with more granularity, again, to be able to kind of point to that. But because of limitations with being able to have enough statistical power and things like that, it is harder to conduct studies that look at increased risks at closer distances. So, and again, I'll just add one more time that I think that distance is an important metric to consider when looking at potential exposure, specifically to air pollution associated with oil and gas development, but density is also important, as is, the population density and number of people that may be exposed, and also, the demographics, what's the cumulative burden for that community, where are their sensitive receptors, all those additional considerations should also be taken into account when considering setbacks or other protective measures.
I'm going to take a question that was just submitted and also add an additional question to it, or kind of broaden it as well to so there's a paucity of research, right? I mean, we know that there is only one study in California. We can talk about the studies in Colorado as being applicable to California for the reasons that you stated. And then there's also this whole piece of there isn't science to say, there's so much that's undisclosed that there is no research on that we can't speak to, right? Because that research that can't be done. And again, I would pose this, Leanne, to you and to Linda as well. How do you think we can address that? What is the most effective way to speak to the fact that there isn't a lot of data on all of this?
I think being specific about where the uncertainties lie is important. So having specific examples of where there are uncertainties and recommendations and how we can kind of close those information gaps. But I think also from a public health perspective, when you have uncertainties, safety isn't necessarily assumed. And so making that really clear, and that, again, I think comes back to what Linda originally was stating, which is the precautionary principle and approaching things from more of a preventative standpoint. And again, uncertainty does not guarantee safety. Linda, did you have more to add to that?
No, I think that's just a really key point. I've just been reading some of the risk communication stuff that's coming out on coronavirus, and one of my risk communication gurus, Peter Sandman, just published a really interesting blog about the absence of evidence is not evidence of absence of impact.
Right.
And that's where we're at with this.
Well,
I'm going to ask one more question, and then I think we will start to wrap things up. For many of us on the call here are in Northern California, where we live very close to refineries, not necessarily to wells. How much of this research, or are there other bodies of research that we should be looking at to look at the health hazards specifically related to refineries?
Yeah, I think that it's a great question, and I think the most relevant pathway that we discussed today would be an air pollution pathway. I'm happy to provide some additional research and resources about what emissions look like from refinery sources. There's emissions reporting requirements that refineries in the state have to meet, and so annual emissions of certain toxic air contaminants and criteria pollutants are available online that I'm happy to share. And I believe there's there was one study published last year that looked at, I believe, birth outcomes associated with proximity to refineries here in California. And I could pass that on as well. But there may be overlap when it comes to hazardous air pollutant considerations and air pollution exposure.
This is Linda. That was a great question, but the other thing I do want to tag on is that I don't think we should neglect the impacts of climate change, because ultimately the reason we're extracting oil and gas and refining it is to burn it. And it's the combustion of fossil fuels that's contributing to climate change with all of its impacts. So I think we do need to incorporate that into our comments.
Sure.
All righty, guys. Well, I think we will probably end things in the next minute or so. Leanne, thank you again so much. We are incredibly appreciative of your time and your expertise. And thank you for putting this together and sharing it with us. I do want to put in a plug again. I'll post it again in the chat in a second, but at the very beginning of the chat, I posted a link to a Google form. If anyone on the call hasn't filled that out yet, please do so. And that's what we're going to use to collect information about people who are medical providers and the public health professionals who are planning to go to the pre-rule making meetings in Oakland and also throughout the state. So if you haven't filled that out already, please do so. And please feel free to forward that around to colleagues or people people who weren't on the call, weren't notified of the call, but who may be attending, because we'd like to be organized and have some sort of key messages already decided upon before going into these meetings. So we will be in touch. Later today, I'll post this recording to Slack, and then we'll also be reaching out to everyone who has indicated that they will be going to one of the meetings in the next day or so to start organizing around what exactly we will all say. Leanne, so I'm going to post your slides as well, and we would love to get any of the specific follow-up studies that you mentioned. And someone is also asking whether it's possible to get copies of the McKenzie studies. Do you have those easily to share out?
Yeah, absolutely. So I may have made just a couple tweaks to the presentation, so I'll send you a new PDF so you have the updated version that I shared today, and then I'll send along this lit review that I've referenced multiple times during the talk today, and I'll also send over a couple PDFs as well.
Fabulous.
Awesome. Excellent. Well, thank you so much. I'm going to post a link to the form again in the chat. A few people are saying they don't see it, so I will put it in the chat again right now for anyone who's not seeing it. And again, thank you to everyone. And please feel free to reach out to me directly on Slack or email with any additional questions or comments. But thank you guys, and thank you again, Leanne.
Yeah, thanks for having me.
Thanks so much, Leanne. That was terrific.
Okay, stay safe out there. All righty, bye everyone.
Bye.